conformance testing has to be separated from robustness testing. In conformance testing, you always verify that all replies are according to the specification. So if the reply is wrong, then it's not a valid, it's a failed test case. In performance testing and in robustness testing, if the test sequence doesn't crash the software or cause memory leaks or performance problems, then it's passed. But if it crashes, if it causes some other selection criteria for failing, if it fits into that, then it's a failed test case. So you don't analyze all the responses, and that's usually even impossible because according to standards, in some cases, if you send non-conformant messages, it's equally valid to just drop the input and ignore it. In some cases, it's equally valid to give an error message. In some cases, you don't want to give an error message even if it's required by the specification, just because of security reasons. So you don't have to have an oracle to verify all the responses. Where can you use security robustness testing? You can do certification, software development, that's the best place because the earlier they are fixed, the better. But unfortunately, many software developers nowadays are not interested in security. They don't have the motivation, they don't have the economics to actually calculate what kind of investments are required for secure development. So in those cases, you have to actually go to the end users. If you have operators, governments, banks who actually know what's the damage when they have security problems, they want to do the risk analysis and acceptance testing as well. And these are the market areas for security consultants. If you look at robustness testing from real-life examples, here's an example from University of Oulu webpage. It's showing test results from testing 9 commercial products that are communicating using SIP, which is voice over IP protocol. Test grouping is based on structures within the protocol itself. You have different header fields, you have different structures within the communication protocol, and you are trying different kind of broken structures within those. It's difficult to categorize these failures, but basically, if you have a product failing in all possible test groups, test categories, it means that hackers would have easy thing to find a problem also in that kind of product. In worst cases, 50% of the test groups or 50% of test cases found a problem, security-related problem. And that means that developers don't have a clue how to program network communication software. In some cases, maybe because of using Java or some other more reliable programming languages, they get less problems. But still, there are extremely few products that don't have any problems at all. No matter what programming language, no matter what operating system, and so on. And even products from the same vendor have huge differences because it's still because of people making mistakes, and you have different kind of people in different development teams. You have different kind of software development practices in different development teams. When you have a group of 10 to 1,000 of test cases, it doesn't mean that all the test cases within that group find problems. Sometimes you can have, for example, in the username password combination, if a valid username would be less than 8 digits, characters, then software might survive tests until, for example, 100, 200 characters. 201 causes a crash, 202 again survives. So it requires more than 1 to 10 test cases to find different kind of problem categories. And it's not every test case within the group that finds a problem. And when you find a problem, then you have to verify what kind of problem it actually was. Here we have Tls Handshake, and on red is actually a length field within Tls Handshake message. So defining different length within the packet compared to the actual content can cause the software to allocate too much memory and crash and fail, trying to read more data than actually fits into the buffer. Typical buffer overflow, but it's based on actually having wrong length values in the protocol. So in here you have ASN1 kind of structure, but it's not ASN1. So you have type version length specifying the packet, and length in this field is actually showing much larger than the actual content in the packet. Systematically going through all fields within protocols, no matter how they are specified, whether they are ASN1 or ASCII based or IETF specified, you have to go through all the data types and use all known inputs that can cause problems there. ASCII-based protocols, just the same. So you have a structure that contains lots and lots of different header fields. Within there, you are inserting line fields just in an unexpected place. And in this case, Java application crashes. I don't know why, but it crashes. Or one problem category is loops or repetitions. So you have, again, a complex protocol structure. Within there, in one field, you are repeating a structure that wasn't supposed to be repeated. And again, you can imagine from programmers' perspective how they would implement this kind of a parser that just keeps on going and never ending a structure. It can either just reserve all the memory, or it can just end up in a buffer overflow again. Security testing and testing in general has always limitations. You can never find all security problems by testing. You can never find all security problems by auditing. Performance testing always finds its own category of errors. You can combine different means of testing. You can run the software under heavy load and then do conformance testing, negative testing, and so on. There's different combinations how you can benefit from it. There's lots of gray box testing tools. There's different tools how you can actually monitor binaries. You can analyze what's actually happening within the software to help you in discovering these problems. And it's all up to actually using risk analysis and best effort in trying to find the problems. I will now talk a little bit about what happens to the rest of the problems. You cannot eliminate all of them by auditing and testing, so what happens to the rest? If someone finds a problem, you have a communication network. You have someone containing often confidential information that you want to have, and usually using some confidential communication channel. So you have finders of the problems, for example, Tiger teams, whether inside an organization or external Tiger teams. You have your own or outsourced or external response teams or coordinators, and you have the actual developers who are responsible for fixing the problems. There are different ways of handling these. If you find these problems internally, you have always the option to do no disclosure at all. So you just fix the problem quietly and forget about it. Don't notify anyone. If the discoverer is using no disclosure policy, hopefully he is disclosing the information at least to the developers. But still, many security companies never expose any of these details to general public. In some cases, especially commercial companies, they disclose